What is the discovery that astronomers plan to make using our new $10 billion telescope? This project will take years to come to fruition, but if all goes well, a journey to Proxima will take about 20 years. So, realistically, we need a few decades to accomplish this mission. Confirming whether there is indeed life on that planet is a centuries-old curiosity that seeks to answer the question of whether we are truly alone in the universe. The James Webb Telescope has made incredible discoveries that bring us closer to the answer to our search for life beyond ourselves, far from Earth. Throughout human history, thousands of media content and theories have been produced on this subject. Our curiosity about our place in the universe and our loneliness has become a lasting feature, as if there is a deep urge within all of us for a search. No matter how alien it may be, we might actually be getting closer to finding the answers. But are these answers really what we are looking for? Or will we encounter more frightening truths? Join us as we explore the latest discoveries between galaxies and planets and prepare to witness the lights. Scientists are working on a big question that was initiated by the James Webb Space Telescope in 2021. Can our future telescopes detect artificial light on another planet? For example, on Proxima B. Proxima B is the closest exoplanet to Earth and is in the habitable zone of our closest neighboring star, Proxima Centauri. The exoplanet is 20 times closer to its star than Earth is to the Sun and is located 4.25 light-years away. Proxima B is believed to have a tidally locked orbit, with a permanent day side and a permanent night side, much like the way the Moon shows only one face to Earth. If there is a hypothetical technological civilization on Proxima B, this civilization could transfer heat and electricity from the day side to the night side using solar panels that generate electricity from the star. This idea was discussed in a paper published by Manas Lingam and a group of researchers. If such solar panels could be detected by future telescopes, the advanced capabilities of the James Webb Space Telescope, JWST, would allow us to extend our search for artificial light to habitable exoplanets like Proxima B. Now in 2024, the JWST can undertake this mission. With its higher sensitivity and broad range of capabilities, it could detect the artificial lights we are searching for and take us to the next great stage of human evolution. But first, let's take a look at the world of planets and exoplanets to understand how these discoveries are possible. The mission of the James Webb Telescope is to investigate the secrets of Proxima Centauri B throughout its history. Humans have always wondered about the nature of the universe. What are we? Where do we come from? And where are we going? These are universal but extremely challenging questions that we have been trying to answer since gaining consciousness. In the age of exponential technological advancement, we wonder how close we are to answering these questions. If you ask a philosopher, they will likely say, "We have made very little progress in understanding ourselves and the universe." However, if you ask an astronomer the same question, they will excitedly start sharing their latest discoveries about the universe. These tools, often overlooked by the public, are a significant manifestation of human evolution. The world is now at our fingertips, and it is time to use the technologies developed by scientists and astronomers to better understand the universe. The James Webb Space Telescope is equipped with the ability to detect artificial lights that might shine on another planet. The James Webb Space Telescope is an instrument born from the legacy of humanity's exploratory journeys into space. The ever-present questions, "Are we alone?" and "Who is out there?" are beginning to find answers thanks to this telescope. While this infrared astronomy tool has started answering these questions, they are not yet fully answered. First of all, you might be wondering what Proxima B, or Proxima Centauri B, is. Also sometimes referred to as Alpha Centauri or CB, this planet is a super-Earth exoplanet orbiting an M-type star. Super-Earth exoplanets are planets that are larger than Earth, but lighter than ice giants like Neptune and Uranus, and are truly unique. They can be composed of gas, rock, or a combination of both, and their sizes can range from twice the size of Earth to up to 10 times its mass. Proxima B is thus called a super-Earth and an exoplanet, meaning it is a planet outside our solar system. The possible first evidence of an exoplanet was found in 1917, but it did not attract much attention at the time. However, the first confirmed detection occurred in 1992, causing a significant stir in the scientific community. Another exoplanet, first detected in 1988, was confirmed in 2003. As of April 1st, 2012, there are 5,653 confirmed exoplanets in 4,161 planetary systems, with 896 of these systems having more than one planet. These remarkable discoveries orbit around M-type stars. Now, to explain the star type, you need to understand the red dwarf. A red dwarf is the smallest type of star on the main sequence and is commonly found in the regions neighboring the Sun. They are not easy to observe for planet detection and other observations due to their low brightness in the Milky Way. These stars have different definitions and names depending on their temperatures and sizes. MD dwarfs, or M-type stars, produce a maximum temperature of 3,900 K, which brings us back to Proxima B's characteristics and names. Proxima B is known to have a mass equivalent to Earth. Interestingly, it only takes 11.2 days to complete one orbit around its star, which is quite short compared to Earth's 365.25-day year. Proxima B orbits surprisingly under the entire electromagnetic spectrum. The total luminosity of its star is only about 0.16% that of the Sun. Additionally, it appears even dimmer in the visible light spectrum, emitting only 0.056% of the Sun's brightness and producing significantly less light energy compared to the Sun. More than 85% of the energy it emits is in the form of infrared radiation. Proxima B, orbiting at a distance of 0.04856 AU, was discovered in 2016. Why do we focus so much on Proxima B when there are millions of stars, planets, and galaxies? There are several reasons. First and foremost, Proxima B is part of the star system closest to the Sun and is only 4.2 light-years away from us. This is considered quite a close distance in the grand scheme of the universe. Therefore, we show special interest in this star system. Additionally, Proxima B is part of a triple star system called Alpha Centauri. Although Proxima B itself has very low brightness, the system appears as one of the brightest constellations in the night sky. It ranks third after Sirius and Canopus. However, the most interesting thing about Proxima Centauri B is that it is potentially habitable because it is within the habitable zone. The possibilities around this star are endless, and astronomers continue to study it in depth. This is where the James Webb Space Telescope comes in. The four primary objectives of the JWST are to search for light from the first stars and galaxies formed after the Big Bang, to understand galaxy formation and evolution, to study star and planet formation, and to investigate planetary systems and the origins of life. As we continue to explore this exoplanet, we are getting closer and closer to completing these missions, from SETI to those searching for alien life. Humans have always been a curious species, trying to explore and understand everything that moves and doesn't move. A search on such a large scale, like SETI, makes sense. Imagine God organizing a great cosmic treasure hunt, but instead of searching for gold, we are tasked with looking for electromagnetic signals, signals from civilizations beyond our wildest dreams. SETI stands for the Search for Extraterrestrial Intelligence and is a collective effort to detect signs of intelligent life hidden among our stars. Does curiosity ever end? In the early 1900s, shortly after radio technology became available to humans, geniuses like Nikola Tesla and Guglielmo Marconi dared to dream of using their new devices to communicate with the stars. Tesla went as far as to imagine using his wireless transmission system to chat with Martians, and fast forward to the 1960s, we found ourselves in the midst of the OSMA project, the brainchild of bold astronomer Frank Drake. With a powerful radio telescope and a healthy dose of curiosity, Drake scanned the cosmic radio waves for signs of life, but unfortunately, his efforts came up empty. However, he persevered. Meanwhile, scientists around the world continued to tune their antennas to the cosmic symphony. In the Soviet Union, the curiosity for cosmic conversations was great, led by the renowned Iosif Shklovsky. Soviet scientists pointed their antennas to the sky in search of signals from the stars, thus setting the stage for a cosmic reckoning. But wait, what happens next? This mysterious signal, piercing through the cosmic noise, was dubbed the WOW signal, sending shockwaves through the scientific community. It was one of the most intense moments encountered in the years-long SETI searches. The scientists at Project Cyclops spared no expense in their quest to solve the cosmic mystery. Then, an encrypted radio signal from Mars was detected by our Hubble telescopes, once again igniting the flames of curiosity. But what does this discovery really mean? In a research paper published in 2021 on the detectability of artificial lights on Proxima B, light was shed on the discoveries made to examine the presence of these lights on Proxima B. How far have we come in space exploration so far? Alyssa Tabor and Abraham Loeb set out to investigate the detection potential of artificial lights arising from darkness. Proxima B was considered a significant target in their study because it is a planet located in the habitable zone of its star. The potential for Proxima B to harbor intelligent life and how it could be detected were examined. The topic of extraterrestrial life is both fascinating and slightly frightening. The detection of a transient radio signal from Proxima B is not new, but the fact that information in the field of science travels across light years makes everything a turning point. It has generated significant excitement among the community of science and astronomy enthusiasts. The transient radio signal added another element of curiosity and created an exciting mystery that astronomers were eager to uncover. This signal, detected by the Breakthrough Listen project, represents a potential candidate for extraterrestrial radio emission. The surroundings of Proxima Centauri, the host star of Proxima B, became one of the focal points of the Breakthrough Listen project, which was launched in 2015. The project aims to survey the sky for signals indicative of technological civilizations beyond Earth. Utilizing state-of-the-art radio telescopes and data analysis techniques, it scanned vast areas of the electromagnetic spectrum to find abnormal signals that could not be easily explained by natural phenomena. The story of the transient radio signal from Proxima B is quite valuable. Astronomers working on the project detected a narrowband emission around 982 MHz, a frequency range typically associated with artificial radio transmissions, like the signals used for communication on Earth. While the observed signal has not been definitively attributed to an extraterrestrial origin and has alternative explanations, this discovery was an exciting step that opened the door to a whole new world of possibilities. This discovery will remain a significant achievement in human history for as long as the signal exists. Now it was time to evaluate the call. The Breakthrough Listen team conducted extensive follow-up observations and data analyses to further investigate the signal, aiming to assess the possibility of it being of extraterrestrial origin. It is currently not possible to draw definitive conclusions because the vast expanse we call the universe contains thousands of complexities, making it far from simple. Disturbances and interferences from terrestrial sources can distort and skew the results. Astronomers cannot proceed with such distorted results. Space exploration requires extreme precision in every aspect and demands significant costs for successful execution. Mistakes are not an option. However, there is always a light at the end of the tunnel. And with the technology we have, we may be closer to uncovering the secrets of the universe than we think. The article emphasizes the importance of artificial lights as indicators of technological civilizations. If our discoveries become truly advanced, it theorizes that planets with a permanent dark side, like Proxima B, might require artificial lighting for technological habitability. The study calculates the light curve considering various factors such as the planet's radius, host star radius, orbital period, or orbital inclination. This is done to predict how easily we could detect artificial lights. It also explains the light curves using the ERL model to calculate the analytical reflected light curve of exoplanets, and introduces a parameter representing the proportion of artificial light on Proxima B's dark side. Using the James Webb Space Telescope, JWST, and its NIR spec instrument, the study simulates signal-to-noise calculations and evaluates the feasibility of detecting these artificial lights. Once the results are gathered, they are analyzed. JWST can detect LED-type artificial lights constituting 5% of the star's power, with approximately 85% confidence. 85% is a significant leap compared to other inconclusive results, but the current spectral band needs to be 103 times narrower to detect the existing artificial lighting levels on Earth. The discussion suggests that Proxima B's permanent day and night sides could be illuminated using strategic mirrors. This clever technique could enhance the detectability of artificial lights. The article concludes by proposing future extensions. Using future telescopes like LUVOIR could be groundbreaking in terms of advanced detection capabilities. JWST is decoding Proxima B's atmosphere. One might wonder how we managed such complex calculations thousands of years ago. Reaching the moon once seemed like a fervent dream, but now we are calculating and analyzing planets light years away. This is very true, and certainly one of the highest symbols of human progress. Our tools, especially JWST, are poised to revolutionize our understanding of exoplanet atmospheres and environments. Yes, this includes Proxima B's. These ambitious plans are intended to be realized through advanced observational capabilities. One of the most important instruments on board is the near-infrared spectrograph, which plays a central role in identifying and ultimately understanding exoplanets. Due to its high sensitivity and spectral resolution, atmospheres can be analyzed using NIR spec. This allows astronomers to separate the light from distant exoplanets like separating two strands of hair. This facilitates the detection of signatures of important atmospheric components such as water vapor, carbon dioxide, methane, and other molecules. Simulations conducted by astronomers suggest that Proxima Centauri b would have to wait about 169 million years after its formation to ensure this information is secure. The exoplanet discovery point that makes Proxima b's habitability highly questionable is that the James Webb era space signals, artificial lights, and superplanets aside, the world of space exploration is dark, uncertain, but exciting. Rapid development not only advances the space research and development industry, but also enables progress at the speed of light. It may not take very long for ordinary average people to walk on the moon easily. For example, NASA and other private companies already have their eyes set on the moon. NASA's bold and exciting Artemis program aims to take humans beyond Earth. This program, which plans to start establishing a base camp on the moon in 2025, envisions a long-term human presence on the lunar surface. These ambitious plans will help NASA prepare for human space exploration beyond the moon and even allow us to reach Mars. As we move forward with this cosmic expansion dream, we also learn to understand and protect our own planet, Earth. The knowledge gained from exploring other worlds can help us understand and mitigate climate change and other environmental impacts. While continuing to explore the universe and search for signs of life beyond our solar system, we must not forget to take care of our precious planet. The recent discovery of Proxima B and ongoing research are just the beginning. With the leadership of the James Webb Space Telescope and new technologies on the horizon, it offers a glimpse into what the future of space exploration might bring. We are closer than ever to answering humanity's age-old question: are we alone in the universe? The journey may be long and challenging, but the discoveries waiting to be made are worth every step. So let's continue to look at the stars with curiosity and excitement, knowing that the secrets of the universe are waiting to be revealed.